Good day to all of you. Today we shall study about keys in DBMS. By the end of today's session, we'll come to know what is the meaning of keys in DBMS and what are the different keys available in DBMS. It's a very important topic which is needed to understand normalization of relations, which forms the basis of any relational database design. So first let us know what is the meaning of keys in DBMS. A key means an attribute or set of attributes that help us to identify a row or tuple uniquely in a table or relation. So in DBMS, that is in rdbms, Relational Database Management System, the real world data is stored in the form of tables. Tables have rows and columns. So the column names are known as attributes. So this key in DBMS will be a single attribute or single column name or multiple column names. Consider student table. In this the attributes are roll number, name, marks. So identify a row with name equal to Aman means that is this row and this row. So there are two rows. Now with the name attribute value only, we cannot identify any row uniquely here. Next, identify a row with name equal to Aman and marks equal to 92 means that is this row only. Identify a row with name Aman and marks 67 means this row only. Now with the name and marks attribute values, we can identify these two rows uniquely. But if you see here in this two rows, the name is Suraj only and the marks are also 88 only. In these two rows, we are not able to identify any row uniquely with just name attribute value and marks attribute value. But identify a row with roll number 4 means that is this row only. So identify a row with roll number 2 means that is this row only. So with roll number attribute value in this table, any row can be identified uniquely because in each row one student details will be stored. Okay, there are 5 rows and hence 5 student details will be stored in the student table. In each row, the roll number value will be different because in real life, every student has different roll number. That is why with roll number attribute value, we can identify any row in this table uniquely. So, roll numbers is the keys in this table. A student may have same name and marks in real world but not roll number. Hence, the keys in this student table is there is only one key, that is roll number, and this key is having only one attribute. What finally we can say in student table here, there is only one key and that is having only one attribute. So this column name, with the value of that we can identify any row in this table uniquely. Okay. Next, considering student table with attributes roll number, name, email ID and marks. So with roll number value we can identify any row uniquely here. With the name attribute or marks attribute we cannot identify any row here uniquely because they may have same values. If you consider one more attribute here, email ID, every student will have different email IDs. So in each row when student details are stored, so every student email ID will have different value. Hence, and any row here in this table can be uniquely identified by email ID attribute value. So in this table we can say then the keys are roll number and second one is email ID. A student may have same name and marks but not roll number or email ID. So finally what we can say, this table has two keys. One is roll number and another is email ID. Each have single attribute. So either with roll number attribute value or column name value, we can identify any row uniquely here, or only email ID, column name or attribute value, we can identify any row uniquely here. Now consider this student table. The attributes are roll number, name, email ID, phone number, marks. We have already come to know that with name attribute value alone or marks attribute value alone, or with the values of both name attribute and marks attribute, we cannot identify any row uniquely in this table. Since roll number attribute value is unique to each student, so by its value any row can be identified uniquely here. Hence, roll number is the key here. Next, if you take email ID attribute, it also has unique value. That is, different students have different email IDs. Hence, any row in this table can be uniquely identified. So, next keys in this table is email ID. One more observation, if you do, that there is phone number attribute. Phone number values also will be different for different students. Hence, by phone number attribute value, we can identify any row in this table uniquely. So, the third key in this table is phone number. Because in real life, the students may have same name and marks, but not roll number, email ID or phone number. What finally we can say that in this student table there are three keys. First one roll number, second one email ID, third one phone number. Each is having single attribute. Hence by column name, roll number or email ID or phone number, by any one value here we can identify any row in the table. Next, consider this books table. Here the attributes are author ID and book ID. Can we identify any row here with only author ID value? No, because here it is 1 and here it is 1. So the author ID is repeated. So there are two rows now. So no row can be identified uniquely only with author ID value. Can we identify any row uniquely here with only book ID attribute value? No, because it is repeated here in 3 rows. So we cannot identify any row with only book ID attribute value uniquely here. Now if you consider the values of both author ID and book ID. So a row with author ID 1 and book ID 1 means only this. A row with author ID 1, book ID 2 means only this. So one author may write multiple books. So which author and which book ID? With the values of both attributes only we can identify any row uniquely here. Hence, in this table, the key is this. There is only one key in this table, but it is having two attributes. Such a key is called as composite key. So what is meant by composite key? Composite key means a key which has multiple attributes. So it is a combination of two or more columns that is used to identify a row uniquely in a table. So in SQL, structured query language, that is the programming language which is used to communicate with database. So in that, these composite keys are used to identify a row uniquely during the situation when there is no single attribute that can uniquely identify each row in a table, and only when a combination of attributes can ensure uniqueness, then composite keys are used to identify any row uniquely in a table. So what finally we can say that in this books table there is one key which is composite key. It is having two attributes. With the values of both the attributes or column names, we can identify any row uniquely in this table. So next, consider this purchase table. Its attributes are customer ID, product ID, quantity. In real world, one customer may purchase different products. So here customer ID is one, that is one customer. He is purchasing a product with ID 345, the quantity being 55. If you observe these two rows here, the customer ID, that is same customer, is purchasing two different products. The first one is having product ID 345, second product is having ID 56. The quantity is same, but the rows can be identified by the values of both the attributes. That is, this is the row where customer ID is 1 and product ID is 345, and this is the row where customer ID is 1 but product ID is 56. The quantity may be same, but any row here can be identified by the values of both the attributes, that is customer ID and product ID, and hence in this table the key is this. So it is having two attributes. Hence this key is also composite key. So what finally we can say that in this purchase table there is one key. It is having two attributes. That is, by both attribute or column name values we can identify any row here uniquely. Next, considering orders table. Here the attributes are order ID, customer ID, product ID, quantity. In real world, in one order, one customer can place order for multiple products. So if you observe three rows here, in order ID 1, the same customer, that is with ID 101, is placing for same amount of products, but the first one is product ID 1, second one is having product ID 2, and the third product that customer is purchasing is having product ID 3. This shows that in this table, to identify any row here, the values of all the three attributes, that is these attributes, is required to identify any row uniquely. Okay. So this row shows that customer with customer ID 101 in order ID 1 purchasing product with product ID 1 of 2 quantity. In this row, the same customer with ID 101 in the same order ID 1 placing the order for same amount of product. The product ID is 2. In the third row, the same customer with ID 101 in the same order ID with 1 is placing the order for same amount of product, but the product ID is 3. That is, the values of all the three attributes are required to identify any row in this table. Hence, in this table, the key is this. There is single key in this table, but it is having three attributes. So, this is also a composite key. So, what finally we can say that in this table, there is only one key. It is having three attributes. It is a composite key. By the values of all the three attributes only, we can identify any row uniquely in this table. So with those examples, we can conclude that a key refers to an attribute or a set of attributes that help us to identify a row or tuple uniquely in a table or relation. A table may have single key or multiple keys, that is first point, and in any key there may be single attribute or set of attributes. But with these attributes, we'll be able to find any row uniquely. That single attribute or column name or set of attributes or column names which is used to identify any row uniquely in a table, that is called as key. Okay. So far we learned what is the meaning of keys in DBMS. Next we shall study what are the different keys in DBMS. What are the different types of keys in DBMS? There are 7 different types of keys in DBMS. They are super key, candidate key, primary key, alternate key, unique key, foreign key, and surrogate key. All these keys are unique identifiers, that is, They may be having single attribute or single column name, or they may be having multiple attributes or multiple columns in identifying a row uniquely. But what is the meaning of each key and what are the differences between each key, that we shall study next. First we shall take up super key. Super key is the superset of all the keys. Super key uniquely identifies any row or tuple in a relational database table but contains unnecessary attributes. For that we shall take an example table, that is employee table here. It is having attributes employee ID, name, SSN, email ID and DEPT underscore ID, that is department ID. So identify any row where employee ID is 1 means that is this row only. So employee ID is the key for this table. That means every employee has different employee IDs that will be unique to each employee. So by employee ID value you can identify any row uniquely here. Hence employee ID is the super key because it is the unique identifier. Next, identify row with employee ID 1 and name John means, so employee ID 1 and name John means this row only. Now this row can be identified by values of both employee ID and name attribute. Hence this is also a super key. Next, identify a row with employee ID 1 name equal to John and this SSN means it points to same row only. Hence with this set of attributes we can identify any row uniquely in the table here. So this is also a super key. Next, identify a row with employee ID 1 name equal to John and this SSN and email ID means that points to same row only. Hence, any row can be identified uniquely by the set of these attributes. It is also a super key. Next, identify a row with the employee ID 1, this name John and this SSN, this email ID and department ID 1 means it points to same row. So, hence any row can be identified by the set of these attributes. So if you take a key attribute, if you form the combination with other attributes, those set of attributes also become super key because they are also unique identifiers. With the values of them we can identify any row uniquely in the table here. So this way we could generate 5 super keys with one key, that is employee ID in this table. Next, let us consider one more key for this table, that is SSN attribute, and generate some more super keys. So those super keys are SSN attribute, SSN attribute with the combination of other attributes, then taking one more key in this table, that is email ID. So with email ID and all remaining combinations, so email ID, that is the super key, email ID with EMP ID, then other combinations with email ID. Lastly, combinations of EMP ID, SSN and email ID. So EMP ID with SSN, EMP ID with email ID, SSN with email ID and many more. And many more in the sense here we have not taken SSN with name. So SSN with name and other combinations we can take. Okay. So to the maximum here 2 raised to 5 minus 1, that is 31 super keys can be formed because there are 5 attributes in this table. So 2 raised to 5 is 32 minus 1, that is totally 31 super keys can be formed. So what are super keys? Super keys are the unique identifiers. They can identify any row uniquely in a table. And one more important property of super keys is it may contain unnecessary attribute. Suppose if you take this super key, name attribute, even if you remove, only with EMP ID we can identify any row uniquely here. So name attribute is unnecessary here. And one more super key which we have not listed, which is there in and many more section, that is EMP comma DEPT ID. This super key, if you consider, if you remove department ID attribute here, only with EMP ID alone we can identify any row uniquely here. So in this, name attribute is unnecessary and here DPT ID is unnecessary. That is the second property of super keys. The first property is it can uniquely identify any row in a table. Second property is it may have some unnecessary attributes and which are called as redundant attributes. And in this super key, name attribute may have duplicate values. And in this super key, DEPT ID may have duplicate values or it may be null also. Suppose if you observe in this table DEPT ID, it is having duplicate values. And it may be null if employee is not assigned any department. So this unnecessary attribute may have duplicate values or null values. And in name case, it will not be null but it may have duplicate value. Okay, so that is all about super keys. Next, super keys is called as the superset of all the keys. Means all the remaining keys that are candidate keys, primary keys and alternate keys can be derived from super keys. That we shall see next. So before going to next set of keys, we shall revise the points regarding super key. Super key uniquely identifies tuples or rows in a relational database table, but it contains unnecessary attributes. For example, if you take SSN comma name, this super key, in that name attribute is unnecessary. It may have duplicate values, but it cannot be null. Another super key, if you consider SSN comma DPTID, so this DPTID is unnecessary attribute. It may have duplicate values or it may have null values also. So hence a super key may have some attributes having null values or duplicate values. Here department ID attribute may have null value and duplicate values also. Then name attribute may have duplicate values but not null values. These attributes are unnecessary and they are called as redundant attributes. So after recalling these points, we shall move on to keys which are derived from super keys. What is candidate key? Candidate key is a minimal super key. In another words, smallest possible set of attributes in a super key that can uniquely identify each row is called as candidate key. Hence, candidate keys are derived from super keys only. Candidate key is a super key in which unnecessary attributes are removed. Hence, it is a minimal super key. All the candidate keys are super keys, but all the super keys are not candidate keys. So taking employee table, here the list of super keys is taken, only few are written. From this set of super keys, candidate keys are derived. The minimal super key is called as candidate key, that is one definition. Second one, if you take a super key and if you remove unnecessary attribute and that becomes candidate key. If you take up any super key, for example this one, go on removing attribute here. Lastly only EMP ID is left. With EMP ID attribute alone we can identify any row uniquely in the table and hence candidate key is EMP ID. Next, if you consider another super key here, in this if you remove email ID attribute, only with SSN attribute we can identify any row uniquely here and hence the next candidate key is SSN. Similarly, if you consider this super key, if you remove name attribute, only with email ID attribute we can identify any row uniquely here and hence the next candidate keys is email ID. Hence this table has three candidate keys, that is EMP ID, SSN, email ID. These are the minimal super keys because from super keys the unnecessary attributes are eliminated till minimum number of attributes needed are listed so that any row can be identified uniquely in the table. This is how from super keys candidate keys can be derived. So candidate keys are the minimal super keys. From super keys, in the minimum attributes needed to identify any row uniquely, only they are taken and they form candidate keys. Next, from candidate keys, primary keys can be derived. So what are primary keys? Primary keys are the attributes or column names by the values of which we can identify any row uniquely. But the most important property of primary key is that it cannot be null and it cannot have duplicate values. What is primary key? In relational databases, a primary key is an attribute or column or a set of attributes or columns that uniquely identifies each row in a table. It ensures that two rows do not have same value, means primary key cannot have duplicate values and it cannot contain null values. Primary key is chosen from candidate keys. One table can have only one primary key. Primary key cannot have duplicate or null values. Now here among three candidate keys available in this table, only one key is chosen as primary key, and that is the responsibility of database administrator who is responsible for maintenance of database. So email ID, if it is taken as primary key, all the employees may not have email ID. Then that value will have to be stored here as null. But primary key value cannot be null. So SSN attribute, if you consider as primary key, all the employees may have social security number, then it will be unique. But if they are not registered and if they do not have social security number, we'll have to store null value here. So better than that, if you go for EMP ID in any organization, all the employees will be having employee ID. Hence, their values cannot be null here and they will be unique to each other, means they will not have duplicate values. So primary key can be employee ID. If employee ID is chosen as primary key, the remaining candidate keys they become alternate keys. So SSN and email ID are the alternate keys. From super keys, candidate keys are derived. From candidate keys, primary key is chosen, and when once the primary key is chosen, the remaining keys in the set of candidate keys become alternate keys. Hence we can call super keys is the superset of all the keys here, that is candidate keys, primary keys and alternate keys. So if you see to the points regarding alternate key, when one primary key is chosen from the set of candidate keys in a table, the remaining candidate keys are called as alternate keys. Alternate keys may have null value. So these two are the alternate keys here. They may have null value. If email ID is not there for every employee, null value will be stored here. If they have not yet registered and got social security number, null value will be stored here. But for EMP ID, null value cannot be stored and it cannot have duplicate values. So column name or set of column names which cannot have null value or duplicate values and with which we can choose any row uniquely, that is called as primary key. Okay. Then we shall see to what is meant by foreign key. Here foreign key is an attribute, say DPT here, which is used to link with another table. So that another table can be department table. So it is linking with the primary key in another table, that is this department ID in employee table. It is linking with primary key of another table, means that is department table. Why this key is needed? Suppose if you take employee Narayan. His department number is 3. So what is his department name means? With this value, that is department ID value, we'll have to go to this department table. There it is linked with primary key, that is DID. So in that table where this foreign key value is equal to primary key value, that tuple is considered. In that tuple, what is the department name? That is marketing here. So marketing is the department name of employee Narayan. So this is how to link with another table foreign key is used. Okay. Primary key value can be used to identify any row in the table. Foreign key value is used to identify any row in another linked table. So this foreign key is linked with primary key of which table? In that table, to identify any row, this foreign key is used. Okay. Now, one more important observation. When we are searching for a department by the value of foreign key, that is department ID, matching it with primary key value in the linked table. So whatever foreign key values are here, they must be present here. That is what is referential integrity constraint. In another words, to assign any department table to an employee, that must be present in linked table. Otherwise that cannot be assigned, because when we search, it must be available. Next, if you try to delete this row from department table, then referential integrity constraint error will occur, because this is referenced by another table, that is employee table here. That is, we cannot insert any tuple in this table, the value of DEPT ID which is not available in the other linked table. We cannot delete any row in this department table if it is referenced by other table. These are called as referential integrity constraints. These are needed for the consistency of data in the database. What is foreign key? Foreign key in a database is an attribute or set of attributes, column or columns in one table that refers to the primary key of another table, establishing a link between the two tables. This relationship enforces referential integrity, ensuring that the data in related tables is consistent and accurate. What is referential integrity? Foreign keys enforce the rule that values in foreign key column must exist as value in the primary key column of the referenced table. Primary keys serve as unique identifiers for each row in a database table. Foreign keys link data in one table to the data in another table. And one more important point is, one table can have only one primary key but more than one foreign keys. Next we shall see to some examples on foreign key. Let us see to an example for foreign key. What is foreign key? Foreign key in a table is an attribute which links with the primary key of another table. Here there are two tables, student table and marks table. Student table stores student details like student ID, name and course. Course means subject here. Marks table stores student ID and corresponding marks. In marks table, if you see this ID value 1101, that student has scored 87 marks. Then what are the details of the students? For that, we have to take this foreign key value 1101, go to linked table, there match with primary key value, that is student ID value. It is found in this tuple. Hence in this tuple, name attribute value is Sanjay and course attribute value is C++. That is why student with ID 1101 who has scored 87 marks, that student name is Sanjay and the subject name is C++. This is how through foreign key, which is linked with primary key of another table, the required information can be searched in another table. Let us consider this example on foreign key. There are three tables: student table, subject table and marks table. Student table stores student details like student ID, student name and age. Subject table stores subject related details like subject ID, subject name and teacher name. Marks table stores student ID, subject ID and marks. Marks table has two foreign keys. One is student ID, another one is subject ID. Foreign key student ID links with other table, that is student, through its primary key student ID. Subject ID foreign key links with another table, that is subject table, through its primary key subject ID. Consider student ID foreign key value 1101 who has scored 87 marks in subject with ID 1. What are the details of student? For that, take foreign key value 1101 to the linked table, student table, match with primary key over there. It is found in this tuple. Their student name attribute has got value Sanjay, age attribute has got value 20. Hence, student with ID 1101, his name is Sanjay and age is 20. Next, find his subject details means taking foreign key subject ID value 1, going to linked table, that is subject table, matching with primary key subject ID there, that value is found in this tuple. Hence the subject name is C++ and teacher name is Mahantesh K. Hence that student with ID 1101 who has scored 87 marks, whose name is Sanjay and age being 20, that subject name is C++ and teacher name is Professor Mahantesh K. This way, through foreign key matching with corresponding primary key in the linked table, one can search for the required information. Through another foreign key linking with another table and matching with the primary key over there, one can find the required information in that table. In the first example, the student table had one foreign key, and in the second example, this marks table had two foreign keys. So in this example of foreign key, that is DEPT ID, which is linking employee table with department table. Suppose if any employee is not yet assigned any department, then this value will be stored as null. Okay. That is, a foreign key can have null value. Here primary key in employee table is EMPID, that cannot have duplicate value or null value. Here in department table primary key is DID, that cannot have duplicate values or null values. And in any table there will be only one primary key, but a table can have one or more than one foreign key, and it can have duplicate value or null value. Okay, and that is all about foreign keys. The two important points that we have to remember is one table can have only one primary key, and secondly one table can have more than one foreign keys. Okay, with that we shall move on to next type of key. Next we shall study about unique key. A unique key is a column or set of columns in a table that prevent duplicate values and can store null values. For example, let us take the student table. In this, the attributes are roll number, name, class, phone number, registration number. Roll number is the primary key here. Primary key cannot have null values or cannot have duplicate values. But the unique key in this table is phone number. So this phone number attribute or column can have null values. Suppose if any students do not have phones, then their values will be null here. But if they have phones, then their values will be unique, different. That is what is the meaning of unique key. And that is the difference between primary key and unique key. And one more difference is there can be only one primary key in a table, but there can be more than one unique key. So another unique key in this table is registration number. This column name or attribute also has different values for different students. If doesn't exist, it may have null value. In a table, there can be single primary key which cannot have duplicate values or null values. But in a table, there can be multiple unique keys which cannot have duplicate values but which may have null values. Next, we shall know what is surrogate key. What is surrogate key? It is also called as synthetic key or pseudo key. It is an unique identifier assigned to a record in a table, which is typically given by the database itself rather by the user. It is an artificial key which is not derived from the application data or natural keys. It is strictly created for the purposes of data analysis, and it is used to identify each record when natural key doesn't exist. For example, consider table A and table B. Table A belongs to school A data and table B belongs to school B data. Here the attributes are register number, name and percentage. In both, the same attributes are present. Table C has both A and table B which are merged. So the problem arises now because registration number cannot be taken as primary key because its value doesn't match with all the records here, though it is holding unique values. In such cases, surrogate key, another column is added in the table which holds the row identifiers given by the database itself, either in increasing order of 1, 2, 3, that is natural numbers, or system date or timestamp, or random alphanumeric values. So with this, we can identify any row in the table. If you compare surrogate key with natural key, surrogate keys cannot be used for searching purpose, whereas natural keys can be used. Surrogate keys are always unique. These keys may have duplicate values. Surrogate keys are stable with time. Natural keys may change with time. Surrogate keys require additional column in table. These are already present, do not need additional column. Surrogate keys can run the queries fast. Comparatively, natural keys run the queries slow. Surrogate keys are small in size, whereas natural keys are bigger in size. Surrogate keys plays an important role when natural keys are not available. Then these can be used to identify any row uniquely. That is all about surrogate key. Next, we shall know why keys are required in DBMS. In DBMS, the keys are required to identify a row or tuple uniquely in a table or relation. A key is also used when we want to establish relationships between the different columns and tables of a relational database. We use a key for defining various types of integrity constraints in a database. Primary key, which cannot be null and cannot have duplicate values, make every row unique and identifiable. Indexing is a technique which uses a search key and pointers which reduce the number of disk accesses, optimizing the search time in a database query. And that completes the discussion on keys in DBMS, in which we discussed what are the keys in DBMS, what are the different types of keys in DBMS, and why the keys are required in DBMS. I hope you understood. Thank you.